We've got a real treat. Coming up, we have an orientation to the nutrient cycling regulation landscape with one of its foremost experts, movers, and shakers, Matthew Lippincott, who is then going to bring us into a state-to-state peer exchange about how those things are going, which will feature some other folks. But first, just to give a brief introduction of Matthew Lippincott, friend, colleague, real gentleman and scholar. He is a regulatory consultant with the Civil Engineering Department at the University of Michigan and a part of the asset research team. He also makes kites. I don't know, if you're just like, can I be a Renaissance man? Can I do it all? Matthew says, yes. Matthew, I see you. Take it over. We're glad to have you.
Thank you so much, Sean. Great to be here. I wish I could be there in person with all of you. Um, Today, I'm going to talk very quickly, and well, about 20 minutes, but about the regulatory landscape for urine recycling. We focus very much on the United States, but I will try to touch on other international standards and European standards. Um, we're then going to move into a discussion about how we can further standardize urine recycling and work cooperate internationally. And looking forward to having that broader discussion here with um, everybody who is joining us. So let me share my screen without further ado. There we go. So as Sean mentioned, I'm the regulatory lead for the asset program. And let's get into our vision for the future of urine recycling, which is to have a full cycle from excretion, storage, transport, sanitization, the manufacturing of fertilizer, the growing of plants, and consumption. So if we could circularize the whole nutrient cycle, we're going to require a number of different permits. We need to get occupancy permits, which is to say approval for the plumbing systems, and we need toilets approved in the United States. The regulatory term would be water closet, so like using the Britishism in an official sense here. Um, and so, yeah, we will need to get those sorts of permits. We're also going to need some sort of agreement for shared infrastructure and shared collection systems between multiple buildings or municipal sort of utilities for urine. We're going to need collection programs and a way to fund them, transportation systems that are licensed for hauling, treatment system licenses, permits for the fertilizer, ways to manage those nutrients on farms, and a way to label products grown with urine-derived fertilizers so that consumers feel a part of this and supportive of the program. And if all of that seems totally overwhelming and like a lot, it is a lot. But we don't have to focus on all of these all at once to get a urine recycling industry going. If we narrow this down to the simplest use case, which is really like a large building with a treatment system in the building producing fertilizer. We have a few examples of those, and this simplifies the type of permitting we need to get. We really just need that occupancy permit. We need the toilets approved. We need the treatment system licensed and the fertilizer output licensed. And if we don't focus necessarily on edible crops, then the whole agricultural labeling strategy and nutrient management is a lot simpler. So let's start with the toilets themselves. Now, there's one flush toilet that meets approved standards, and that's the Lauf and Save meets European toilet standards. It does not meet the US toilet standard, but because it meets the European standard, it's easier to apply for a variance for that. When we talk about dry toilets, at least in the United States, there are some requirements for them in the NSF 41 standard, as well as the IATMO WE stand, but these are kind of very simple structural requirements, and there's no specific testing. So for NSF 41, it covers a whole composting toilet system and says the manufacturer would specify the fixture. So there could be a lot more here, but we can get approvals for these toilets. And it would be nice to work on some more standards for that. We hopefully will get some funding at Asset to work on that next year, and can pull together some of you all and other people in industry to work on that. The next part would be the occupancy permit and the plumbing side of things, the piping. And I'll get back to this if we have time. But we started on the Recode Model Code in 2014. Many of you have been involved, especially the Rich Earth Institute and Greywater Action over the long term on this. And we had some real success last year. So we got urine separation approved for an appendix to the 2027 International Plumbing Code. This isn't finalized, but we had no comments on a committee approval. So it's pretty close to there. And that's really exciting in terms of simplifying getting occupancy permits in 34 US states. So again, I'm not going to give like a full check mark, but like a light check mark. We're getting close on that. We have a strategy going forward. On the fertilizer side, we're facing this question of what is urine. It's not really clear that it's sewage sludge or biosolids, and the FDA agrees that it's not solid. It doesn't really seem to fit the definition. And so in the Food Safety and Modernization Act, which is the only time the federal government's mentioned urine as a fertilizer, and in response to a comment, the FDA has said they don't think it's a biosolid. It's probably not solid waste, at least in Michigan and several other states. It doesn't meet the test for solid waste, mainly because it's not solid. Um, and then for reclaimed water, there are a number of reclaimed water regulations in some US states. Most states that have reclaimed water programs, urine has too many nutrients to meet them, although I'm not sure if Madeline Dubois talked about this in her presentation. The Land Institute is looking at those rules in Kansas, and we can talk more about that. But yeah, so what we know, urine is urine, right? It's classified as a human waste by the FDA. Then they put some limits on it. They've said it can be recycled into fertilizers, but it can't be used on raw vegetables for commercial sale. But those fertilizer permits are up to individual US states. And so we have some progress here too. In Michigan, we had success in September. We were approved to have sanitized urine as a specialty fertilizer, which is really exciting precedent. Nutrient Recovery Services in the PAE building last year, they got their urine-derived ammonia and struvite approved as fertilizers in Oregon. And then in Vermont, the Rich Earth Institute has a license for sanitized urine as a residual, as an EQ biosolid. And the state of Vermont has not made an official determination whether they consider it a biosolid. But these are really exciting. We really want to keep urine in this fertilizer category. That'll really help not just simplify the production of these urine-derived fertilizers, but licensing and reuse. So those are a few permits. So those are good, but we're engaging with the American Association of Plant Food Control officials as the asset program to try to put some definitions in at this group. APFCO is a nonprofit body that coordinates state fertilizer regulators. So we're going to try to work over the next several years to define urine with them. And this may help expand these fertilizer license categories to other states. So I'm going to put an even lighter check mark on that. We have some strategies there. The next question, though, is what do we do about treatment? Where do we go on the treatment system licensing? The actual licenses themselves in the United States, they're normally at the state or county level, depending on the state. And so there isn't a clear sort of national or even state level process for defining a urine treatment system, but there are ways that we can work on those standards. So there are some guidelines. We have WHO guidelines. I believe these came out in 2003. We have the EPA biosolids guidelines, which are pointed to by the FDA and others. And some limited set of these are in the anti-atmo we stand, which is the standard that's been used for um, plumbing systems that are installed in large buildings. But these are really treatment guidelines. They don't quite meet the definition of a standard. So we think about like what is a standard? There are three core things that it needs. It's held with an accredited and recognized body, such as the ISO, or in the United States, ANSI, or another ANSI approved body. So there's like an ANSI process that different standards bodies use. It contains requirements, and something like the We Stand contains requirements, but it doesn't meet this third one, which is that it specifies a means of assuring compliance with those requirements, usually through testing. And then normally those tests meet standards. So it's standards all the way down. So we do have, through the Gates Reinvented Toilet program, this ISO standard 30,500 for non-sewered sanitation systems. It was also approved as an appendix to the 2027 IPC, and hopefully moves forward there as well. And it is a full standard, and it references three testing standards, one for water, one for solids, and one for liquids. It does not specify anything about urine in particular, and it doesn't really talk about the fertilizer side of things. But if you look at these, they're mainly Clostridium focused. And so the big question I'd like to frame for our discussion going forward are, first, I'd like to ask our European colleagues about what standards you're asked to meet. And then I'd like to move into some questions about what might help us on our permitting processes with local regulators. Would it be helpful to have a third-party certification that certifies treatments that meet that standard? In the development of a standard, what sort of tests do we need to make of urine that would give assurance to regulators and to consumers? And which of those tests would be affordable and reasonable? So with that, I know Michelle Reichman and Michael Reichman and Kai are here along with Nancy in person. And so let's open it up and have a discussion. Thank you.